Okay, so peace, kings and queens. So I know that we've done, for you algebra folks, we've done a lot of different things, talking about functions, talking about linear equations. I know it's not really sinking in all the way, but I want to change gears a little bit. We're still going to be talking about functions and linear equations, but one thing that may help us understand and internalize this concept a little bit better is the idea of rate of change slope. So I know we didn't finish our notes from today, but we'll come back to that tomorrow in class. So if I look at the part for the topic or objective for my notes for homework tonight, it says rate of change and slope. And my essential question says, how do you find the rate of change and slope of a linear equation? So the first thing we need to do, like we do all the time, is to fill in our vocabulary.
Carmelo Sandoz, please come to the main office. Carmelo Sandoz to the main office.
We need, shout out to Carmela. All right, so we need to figure out our vocabulary word. So it says blank is a ratio that describes on average how much one quantity changes with respect to a change in another quantity. If x is the independent variable and y is the dependent variable, then we have the following equation. So the word that's going to go here is going to be rate of change. All right, that's pretty self-explanatory. We want to figure out how consistently things change over time. So when we talk about my formula for the rate of change, we talk about the change in y over the change in x. And all that means is when I'm talking about the change in y, is we're just taking the difference between two y values and the difference in two x values. Remember, the word difference just means subtraction. So if I look at the first part, it says find the rate of change. I have a problem. It says entertainment. Use the table to find the rate of change, then explain its meaning. So I have the number of computer games, and then I have a total cost. So when I'm talking about computer games and the total cost, I have all of my X's listed and all of my Y's. So from my total cost went from 78 to 156, and then it went from 156 to 230. Remember, my rate of change is going to be equal to, all right, so my rate of change is equal to the change in y, that's what that triangle means, and your change in x. So, let's make that an equation. Let's talk about the difference between 156 and 178. So I have 156 minus 78, that was my y value, the change from 156 to 78, over the change in x, so from 4 to 2. What's that difference? How did I get from 2 to 4? So on the bottom I want to subtract 4 minus 2. So if I simplify that, 156 minus 78, okay, that's going to give me 78, I believe. 78. All right, and then 4 minus 2 is going to be equal to 2. Now, if I divide that and simplify that, that is going to be 39. Okay? So that basically means, so for 2 computer games, it costs $78. If I had 4 computer games, my total cost was 156. 6 games was 234. But now that I've simplified this down into my rate of change, we can say that each computer game is $39. I'm going to abbreviate. Each computer game is $31. So for one game, we would have 39. Because remember, if I go back up here and simplify, if I simplify this by half, this would be 39 over 1. So the number, my total cost over the number of games. Okay? So let's keep looking. The next part says determine whether each function is linear, and I want you guys to explain. So doing the same thing, I want to talk about what it means to change. So when I got from here to here, I want to figure out if this rate of change or is going to be linear. And I'm going to do that by doing the same thing that I did above. So if I start with the change in my y from -8 minus -6, and then do the same thing for my x's, and I get 4 minus 1. If I simplify this, okay, I get -8 plus 6 over 3, right? So then that's going to be equal to -2/3. So that's my rate of change from this first order pair down to this second. Now if I do the same thing for -8 and -10, let's try it. So if I have -10 minus a -8 over the next group, I have 7 minus 4. This is going to be equal to -10 plus 8. Remember, a negative times a negative is a positive, over 3. And then -10 plus 8 is -2 over 3. Okay? If I were to keep doing this same process all the way through my entire table, I would get the same exact rate of change. So since my rate of change is the same, it is linear. So since my rate of change is the same, it is going to be linear. Now, if I was to do that same thing, with another table, let's go ahead and draw this table over here. If I do x and y, and then I had the values -3, 10, and I did -1, 12, and I had 1, 16, 3, 18, and 5, 22. Okay? I do the first one from here to here. If I did 12 minus 10, remember the change in y, so I'm subtracting 12 minus 10, and then -1 minus -3. This would be equal to 12 minus 10 is 2, and then this will change to -1 plus 3, okay? Which is equal to 2 over 2 or 1, okay? So that's what that one is for this rate of change. Now, if I want to look at the same thing from 12 to 16, let's see what that one gives me. If I do 16 minus 12, same process, over, so now I'm looking at this set, 1 minus -1, okay? I would get 16 minus 12 is 4, over, remember this changes to a positive, so 1 plus 1 would be 2. I get 4 over 2. And that simplified is equal to 2. Now, if we look at the difference between these are not consistent. They change. So therefore, this is not linear. All right, it's not linear because the rate of change is not constant. The rate of change is not going to be constant. So this will make a little bit more sense once we flip this paper over. So let's look at the next page. If I look at the next page, this is all talking about slope. So it says the slope of a line The slope of a non-vertical line is the ratio of the change in the y-coordinates, which is our rise, how much we rise, go up or down, and the change in the x-coordinates, so how much we run, how much we move from left to right. So there are two formulas that I've highlighted on here, your slope formulas. Your first one is going to be slope equals rise over run, and we're going to use that one when we're talking about graphs. So slope equals rise over 1 deals with graphs. Okay? And then n equals y2 minus y1 over x2 minus x1 is going to be for ordered pairs. So the variable m stands for slope, and that'll make more sense when we talk about slope-intercept form. Okay? The variable m stands for slope. So now if I look at the first problem that I have on here, it says I want to graph the line that passes through -1, 2, and 2, 4. And all that means is that I want to plot those points. So let's look at -1 and +2. So I go to the left -1 and up 2. So that point is here. And then I go to 2 to the right and up 4. So that means I should get this line right here. So when I draw that line, remember when I have a graph, in order to find the slope, I use the equation rise over run, excuse me. So all this means is I have to start at one point and then figure out how many I rise. So if I start at this point here, I went up 2, I went from here and I went up 1, 2. Alright, I rose 2 from one point, and then to run to the next point, I went over starting here, 1, 2, 3. So my slope is going to be equal to 2/3. So you have to start with one point and figure out how many you rise and then how many you run. So let's look at number 2. So number 2 says to graph the line that passes through -1, 3, and 2, -2. So let's plot it. If I start with -1, 3, to the left 1 and up 3, okay? And then 2, -2 will be down here. So remember, 2 points determine a line. And this is the line of my graph, okay? So remember, I want to figure out how many times, or I want to figure out what my slope is. Remember, once again, my equation when I'm finding the slope of a graph is equal to rise over run. So usually when we do this, we want to look at the points moving from left to right. So let's start with my first point. My first point was right here. And in order to get from this point to this point, I have to go down this time. So I'm not rising, I'm actually falling. I have to go down 1, 2, 3, 4, 5. So I went down -5. And I'm running positive. So I'm running 1, 2, 3 to get to that point. So when I fill in my values, I rise, or I fell, -5, and then I ran +3. So my slope is -5 over 3. Okay, my slope is going to be -5 over 3. So let's keep working. All right, let's look at the next part. It says, find the slope of a line that passes through each pair of points, -2, 0, and 1, 5. So this time, I just have the ordered pairs. I don't have a graph. I don't have any of that. So I want to use the equation that we have up top. So if I look at the equation, I have m equals y2 minus y1 over x2 minus x1. Okay? All these letters just mean the parts of our ordered pairs. So when I talk about y2, I want to look at the y value in the second order pair. So my second order pair is going to be 1, 5. Okay? The one that has the y value is going to be 5. So this is going to be y2. When I'm talking about my first order pair, the y value is 0. So y2, I'm going to have 5 minus 0 over x2. I'm going back to the second order pair, looking at the x value, and I'm looking at the first order pair, the x value. So I have 1 minus negative 2. So this is easy. From here, we can just simplify this. I have 5 minus 0 is 5 over 1 plus 2, which is 3. So that means that my slope is going to be 5/3. Okay? Slope is going to be 5/3. What I want you guys to do is, let's stop here. And we are going to finish the rest of these problems in class tomorrow. Okay? So, actually, I take that back. Let's try part B. I want you guys to find the slope of B. The order pairs -3, 4, and 2, -3. And then we'll talk about C and D in class tomorrow. Okay? Please make sure that you're studying your notes and that we're going over every single thing that we have thus far. Have a good one.